Good evening, and thanks for joining us. Tonight, we are going to take a look at the 8 most recent ACT exams, which I'm sure Tom and Jeff, as putting this together, probably took a couple minutes. It probably doesn't take long to compile the 8 most recent ACT exams. Of course, I'm just kidding. I'm sure Tom and Jeff spent a lot of time getting this ready for you. So I'm really excited to present this tonight. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Again, with us tonight is Jeff McCullough and Tom Reardon. Jeff's from Memphis, Tennessee, and you may know him from his best-selling book, the TI-Nspire for Dummies. I believe, Jeff, that was for the TI-84. You can correct me if I'm wrong. I think you've had a couple of editions there. And Tom's been around for a couple of years, too. He taught for a long, long time and now currently works for Texas Instruments in product strategy and development. So, Tom, it's great to have you with us, too. So let me just welcome Jeff. Jeff, was I okay with the TI-Nspire for Dummies? Was I correct there?
Yeah, and I just updated the TI-84 for Dummies to include all the new operating systems. That's just out on Amazon recently. So,
very cool. And Tom is with us. So, Tom, great to have you with us as well.
Mike, hi everybody.
All right, Jeff. I think you're going to do some reading for us, talk about the agenda, and then in a minute the expected outcomes for tonight.
Sure. So we're going to talk about a few activities and, talk about actual ACT questions. We'll talk about strategies. In fact, sometimes we're more interested in the strategy than just the answer to these ACT questions we're going to show. We'll talk about lots of cool calculator ideas. We're going to try to hit both the 84 and the Nspire. Quite a bit, at least, showing one or the other, or show screenshots of the other one. And I think at the end, Mike's going to have a webinar drawing, which is always fun.
Absolutely. And then just keep on rolling here, Jeff. Some of the expected outcomes for tonight.
Sure. I mean, I think you get more familiar with the, the test questions themselves, and then certainly more familiar with the technology. You can do the math on the technology. And maybe even understanding the math. And Tom has written some interesting programs. I think that even a way to practice the math that we're doing.
Awesome. Thanks so much, Jeff. So tonight we'll be using the chat window to send general messages, but feel free, if you have any questions for Jeff or Tom at any time, use that Q&A window on the right side of your screen. Again, that chat window, we'll be sending general messages back and forth. And as a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. But the other thing I wanted to make known to everyone, we normally wait to give you the documents until the very, very end of the webinar. And Tom and Jeff said, hey, you know what, let's change that for tonight. So I'm going to put in the chat window, in case you didn't get it yet, the bit.ly link that Tom created for all the documents that they're going to be using tonight. Feel free to grab that, and that way you can sort of follow along with Tom and Jeff as they work through things tonight. Tom, let me give you control, and you can share your screen.
Is it sharing?
No.
Not yet.
Sharing? There we go.
There we go. All right.
Okay, good. All right, well, hello, everybody. So this is the website that Mike was alluding to, and there are really just some programs there on the 84, and then also one file on the TI-Nspire. Essentially, the one for the period and amplitude is one we're going to look at, but you can download those to your calculator or to your TI and to your TI Smart View, or you can just watch me do it. But some people say, oh, you know, we really like to have those ahead of time, so we thought we'd try that. So starting off with a quote, I found this poster a while ago. Human brain is awesome. It functions 24 hours a day from the day we were born and only stops when we were taking an exam or fall in love. So this one kind of gets you there.
Oh, wow.
And by the way, much of the material I'm sharing with you, I just did with students today, high school close to where I live. I volunteer, do the ACT and SAT training. And so you are the second people to see these. So how Jeff and I prepared for this, we got the tests from 2020 and 2021, 2022, and the last 8 tests and just did every single problem. I've made a pile, cut them out, put them in different piles. And the ones that were most popular, we created student activities about. And we're going to share some of those with you, not all of them, that's for sure. But I'm sure you can imagine it took quite a long time just to take those problems, let alone sort them and then, you know, develop things. So this is from my office here. This is just some of the piles. Probably piles is not a word. That's kind of when you talk about dogs have piles, maybe stacks. So, all right. So PowerPoint. Some of you might have seen this before, but I think it's pretty essential, and I'll go through this fairly quickly. So ACT test, 60 questions, 60 minutes, 1 minute per question, right? And the answer is no. Okay. That's one of the first things, make sure your students understand. They go from easy to difficult, and we suggest the first third, about half a minute, next third, about a minute, and that leaves you 90 seconds for the more difficult problems on average. 30, 60, 90 is suggestion, and you've all heard 30, 60, 90 somewhere before, I hope. Calculator information, can use a graphing calculator on every single question. Sometimes it's quicker, sometimes it isn't. It varies by individual student, okay? A lot of things on the ACT, I'd say, oh, you shouldn't even use a calculator on, but this is a high stakes exam. They can use it and they feel more comfortable. It's not cheating. But we're suggesting that we teach not only how to use the calculator on the actual test, but how to teach the concepts daily so that they remember the material much more, a lot longer. Use it as a teaching and a learning tool daily. And this is something that we came up with while we were doing this with ACT and SAT. Standardized exams assess the topics we teach, but they ask questions very differently from how we do on our assessments and how textbooks ask questions. And we came up to the conclusion this has to change. And the best way to change that is to do at least one problem a day, even if it's not on topic, so that they get used to how those questions are being asked. And I think Jeff would agree with me on, hopefully on that one.
I actually do that in my classroom, and it just, you know, the bell ringer or whatever you want to call it, where you start the class with the class problem and just get some thinking and working. So I think it's a good way to start.
And then also, I know I learned this from you, to find out, walk around and see how they do things, because they sometimes come up with ways that are legal, but they don't think they are because you didn't do them that way.
Yeah.
And this gives our students a lot more ammunition, I think.
Yep.
Okay, so this is not a quick fix, but helps students understand the math better and longer. I'm going to go back to my high school Algebra 2 teacher who shocked us one day and said, I'm not trying to get you into college. And we thought, what do you mean? He said, I'm trying to get you out. So thank you, Mr. Erickson. We want the mathematics to last, okay? All right, so how we use the graphing calculator, teaching tool, learning tool, discovery tool, look for patterns, discover formulas, check answers, visualize graphs, thinking graphically is a biggie, visualize solving equations, and solve tougher application problems that are pretty tough to solve by hand. And also, we're going to be using some like e-flashcards tonight, as you'll see, to review concepts. I know that's kind of quick, but just want to make sure I got that out of the way there. So let's go ahead and look at some problems. Oh, before we do that, I do want to know our audience tonight. Please respond in the chat window so that I know who's doing what. If you're an 84 user, just type in 84 there. If you're an Inspire, just type in N. And if you're both, type in both. And Jeff's going to look at that and kind of give me the results in a minute or two. So, and if you don't vote and I don't talk about your calculator, that's on you. Okay, so
So
I am going to
surprising
show.
number of both. 84 is more common,
Okay,
but definitely a number of Inspire users as well. But
okay.
84 is the most common, I would say.
Okay, so I'm going to do a lot of things on the 84, but I also have screenshots of how to do it on Inspire. And
Okay.
if someone says, "Oh, wait a minute, I don't exactly see how you did that," say something in the chat, and Jeff will get my attention.
Yeah,
Okay.
I'm really watching that chat window. We have one TI-83 users who's old school, obviously.
Okay. All right. Well, I'm old school too. Real old school.
They can't do those
Okay.
fraction templates on the 83 though. I mean, oh, I feel bad for the 83 users out there.
Yeah. Yeah. Okay. So we're going to start off with what I did today with the students at Upper Arlington High School. Um, Fractions, LCM, GCF are still on the test. And Jeff and I found that on average, there are about 3 questions per exam that deal with these topics. And these are the topics that they'll do, like take fractions and subtract from the total. Averaging fractions is almost on every single test. Calculation of the fractions sometimes, and then LCM is on there just about every exam. Okay, so let's look at this one here. This is a sample problem. Cheney High School was actually the high school I went to, so I use this in the name. And so take a look at that problem and think about different ways that this could be solved with or without technology. I, of course, will be talking more technology because that's what we're about, but we want them to be able to do by hand as well. So let me give you a few seconds to read that and think about it. And so I call this one fraction subtract from total. And I'm not going to actually do it for you. I'll illustrate. I'll do some more fraction things a little bit. So if you're an 84 user, you can use the fraction template. 1 minus 2/5 minus 1/3. Say subtract all the fractions off from one whole set of students. Okay. And there are 3/20ths left. And I just press the time sign. 600. It takes the last answer and multiplies by 600. So there are 90 students. Similarly, on the Inspire, the fraction template is found by pressing Control Division. You get the quick fraction template. And so someone asked about the fractions, and I'll show that on the next example. Okay. So averaging with fractions, I do want to do this one with you. Okay. So a lot of times I'll say, what's the rational number exactly halfway between these two, which means you have to add them up, divide by 2. Some people will get a common denominator and play around with it that way. Again, I'm going to kind of be suggesting the technology because that's what we're here for. So for this one here, I'm going to go ahead and press alpha followed by x t theta n because I have a color calculator that has a recent operating system. And what I'm going to do is I'm going to add those 2 fractions in the numerator. So I'm going to do that fraction template again and type 3 and then down arrow 16. And I'm still in the denominator and the right arrow is being shown. Say to get out of here, press the right arrow. Plus, again, the fraction template is alpha followed by x t theta n. 7 in the numerator and 32 in the denominator. Right arrow gets me out, right arrow again gets me down to the denominator, and I want to divide that by 2. So I'm finding the average or halfway between those 2 fractions. Press enter, and there's the answer, 13/64.
It's really neat that you can do a fraction within a fraction. I mean, you know what I'm saying? Like it's just handy for students to be able to do that. I think when some of our students, their mind goes to mush when it's a fraction question. If you said average these 2 numbers, they could do that no problem. But fractions, oh my goodness, it's like it just causes issues with their brain synapses.
I agree. Yeah, I agree. And that's why using the calculator, if they're comfortable with it, it gets that out of the way and they can spend more time on other problems. So this is what it looks like on the 84. This is what it looks like basically on the Nspire, okay? Done very similar. Again, to get the fraction template, control division gets you the fraction template on that one. Now, Jeff, you said you didn't like fractions. Look at this one. This is number 39 from a particular test.
Oh my goodness.
And what was weird is the students here, when I showed them today, a lot of them did it mental math, which I was very impressed. Unfortunately, not all of them did it correctly, mental math, but like they started here and said, 1 plus a third was 4/3. Take the reciprocal, 3/4, and so on. But you can also type this in on either of the calculators, okay? And again, I'm not going to spend the time to do that. It can be done, but you just kind of type it and just be patient with it, okay? Yeah, using the fraction template on even on this 84 Silver Edition, sure, you can still do that. You could also do this with 1/3, but I highly recommend not doing that because first of all, you get a decimal answer. Notice that since all of these are fractions, you get a fraction answer. And
That's
again,
nice.
on Nspire, also clean looking. And then someone said old school parentheses method. Yeah, you can be parentheses to death on this one, but it will work.
Oh man.
All right, so this is another one that shocks me that's on every exam. What is the least common multiple of some numbers, three numbers? So I'm going to give you a few seconds to think about that with or without a calculator, okay? But because I want that to sink in, I don't want to just show you. I want you to kind of feel like students do for a while. So let me give you a few seconds on that one. All right, so again, I just wanted to give you some time just to think a little bit about it. So for this one here, um, the calculator does least common multiple. So if you press the math key and go over to number 8 is the least common multiple, which is also least common denominator. But here's the issue you got to be careful on. It can only do 2 at a time. So I could find the least common multiple of, let's say, the first 2, get that answer, and then find the least common multiple again of that answer with the number that's left. So I can type in the 60 or put in ANS and then 130. So that's kind of like the slower way, okay, to do that, but it works, okay. Some of the students like the other way where they'll find the least common multiple of 20, comma, then the least common multiple of the other 2. So it's kind of like you do these first, get that answer and do it with the least common multiple of 20. So you can do it in 1 step or in 2.
And Tom, one thing about this problem that I like to emphasize with students is which answers can you eliminate right away? Like, do you see the same 3 you could eliminate right away that I do?
Okay, for sure, F and G,
Yeah, F
because
and G for
they're
sure.
smaller. Yeah, they're
And it's
smaller
easy to
than
see
130.
130 doesn't go into 180. So
Right. I mean,
to me,
that
the
one can be
answer is either
taken out
J or
too.
K.
And I have a sneaking suspicion, Jeff, that if I multiply those 3 together, I get
Yeah,
78,000, which is what a lot of kids will do to find a common denominator, not the
yeah.
least common denominator. And remember, they're out to get you on those answers. So, yeah, good point Jeff made is we oftentimes will have students always look for some answers that they can eliminate right off the bat.
Yeah.
Unfortunately, sometimes they eliminate the right answer off the bat, but that's another day. So again, this can be done also on Nspire if you're not sure where it is. It's under on the calculator number and then least common multiple, and it has the same ID. You can only do 2 at a time. All right, has anything popped up, Jeff? Any questions or
I think we're
clarifications,
doing good.
complaints? Okay. All right, thank you. So this is another one that students don't realize, this is a least common multiple problem, but it's in context, and it doesn't say least common multiple or anything like that in it. Two lights begin flashing at the same time. One is every 12 seconds. We're a third of the way done. The other flashes every 28. How many seconds elapse from the time the two lights flash at the same time till they flash at the same time again? And this is in context. So the way you would do it is, again, is the least common multiple of those two numbers. Again, the most common wrong answer today was 12 times 28, which is a common denominator and will flash at the same time, but it won't be the soonest one.
You know, it's funny, going back to that question, Tom, the first time I read that question, I did not think least common multiple. It's because of the context of the problem. You're not used to, I was like starting to make a table or a list, just kind of like list them out. And so it's funny how the context, you know, about 30% of the test is in context. And so sometimes it's not as obvious what the math is behind the context.
Right, right. And also, I'll tell you what, even though we had just done LCM problems, like you said, the students today, we did this next, and they just like that there was no connection to some of
Right.
them. There was no
Right.
connection
Yeah.
at all. And I said, no,
Yeah.
you're finding the least common denominator of those two denominators, basically. And so we had to
Yeah.
talk about that.
Yeah.
So, good point. All right, another topic that is on every test, functions, and it could be evaluation of function, composition, find domain, find range, and add, subtract, multiply, divide function values. Okay, so all of those are in there. Okay, and so this is a very common one. Given a simple function, find f at -3. Okay, and I do want to do this one because there are several different ways to use the calculator to evaluate this. So I'm going to go ahead and type this into, well, first of all, you can do it by hand. I mean, that's an obvious there. But I'm going to go to y equals, and I'm going to type this expression in for y1, 2x squared plus 6x minus 7.
Oh, you
Didn't do it
mixed the
very
X
well. Yeah, I didn't do it very well. So that will slow me down, that's for sure. Minus 7. And so I have that in y1. And it's disappearing on me, but okay. So I want to evaluate at -3. So one way I could do this is I could go ahead and, ooh, that's a terrible one. That's my fraction or my trig window. So there's a program on here that I'm going to point out right now. Program that I'm sharing with you that I like to use, and it's called Reset Graph. 3, I'm on version 3, Reset Graph 3. So just watch what happens here. What it does is it clears all the y equals, resets the colors, and also sets up some windows that are kind of nice that I'll talk about a little bit later. But it sets up my current favorite window, which is this right here. And this is called the double decimal window. Now, unfortunately, it did clear out that expression, so that wasn't smart of me. But
That's funny.
I can live through that. So watch what happens when I use this double decimal window. So I'll graph it, and it's a really nice square window. Okay, nice looking grid. But when I press trace, notice that the numbers are very nice. They're not all those 10 decimal places that we used to get. They're in steps of
That's
0.2.
jumping by 0.2s.
Exactly. That's why it's called a double decimal window. If I would do a zoom 4, those of you familiar with zoom 4, and I do trace on there, you can see I go by every 10th. But what I did was I doubled the size, okay? If I do zoom memory and go back to zoom recall or zoom previous, I'll get my previous window, okay? And then, like you said, Jeff, I can, it goes by 2/10 instead of 1/10. And so if I'm in trace, I just type the number I want to go to. It assigns that for X, and then it'll give me the value -7. So that's one nice way of evaluating a function is right on the graph. Another way would be using the table. So if I set the table to start at, say, -5, okay? When I go to second graph, which is table, and go down to -3, there's the -7 again. So that's another nice way to get it. And then probably my favorite way is to go to the home screen and evaluate y1 at -3, just using that function notation. So the y variables on the color, if you have the latest operating system or one of them, alpha trace is where all the y variables live. You could do vars, y vars function, the whole deal, but alpha trace is where I get the y variables, and then use function notation, left parentheses, -3, right parentheses. And this is going to go back to -3 and evaluate it just like that. I noticed some of you are talking about using store. Okay, yes, you could also use the table ask method, but I don't want to overdo it here. Okay, so this is what it looks like, graph table function. Nspire has a really cool way of doing this, is you can define functions on Nspire. It's the very first command in calculator, actions one and define one. So you define it using the same variable and then type it just as you see it. So those of you who use Nspire, I think you have a little leg up on that one. I kind of like the way that looks. Anything popping up, Jeff?
Well, someone was mentioning about the programs. How do you activate just some questions about programs. Could you please show where the commands are like to find the programs? On the 84, to run a program, you just go to, if you have it loaded.
Okay, yeah. So yeah, we'll go ahead and do that. So let me add a page here. And so if you went ahead and loaded the programs that I gave you, if you press the, let me make it bigger, press the program key. Now I have mine are either basic or Python minor and basic. So I'm going to go up to because they're towards the end, and you can find reset graph 3, okay? And then just press enter on it, and then press enter to actually execute the program. Is that what you meant, Jeff? Kind of.
Yeah, I think how do you access those programs? And then Gregory says, and I'm not sure I understand the question. He has 84 CE and he doesn't have a fraction to go with alpha, just the letter B is what he said, but I'm not
Oh,
sure.
yeah, right.
Do you understand that question?
So yeah, so he doesn't have the fraction template.
Okay, so you hit alpha y equals, right?
So yeah, so for
Well, that
yours,
is a
yeah.
good thing to check. Is he in classic or pretty print mode? So
Yeah,
hit
so
the
if you
mode
press
key
alpha
just for a
y
second.
equals, if you don't have this fraction template here, alpha y equals has all the fraction commands, number one being the fraction template.
So hit the mode key just for a second there. So he needs to be in math print mode, which he might be in classic. You know what I'm saying? Like it's possible.
Now, if he's not in a color calculator, then he's out of luck because there's no fraction template on the grayscales.
Well, the silver edition, there's a fraction template on alpha y equals
Oh,
on the
really?
silver edition.
Okay. All right.
But you have to be in math print mode. So if he's in
Okay.
classic, it won't show up for sure.
Gotcha.
Yeah. Can you go back to that screen where you did the define function?
Yeah. Oh, wrong way, wrong direction. So here's the define.
Yeah, that define function is really cool. It just because then you can do function composition, f of g of x when you define them that way. And the other thing, y'all were talking about store. I really like the such that command. Tom, do you mind showing them the such that command on this problem for the Nspire?
So let me do that. So let me add a page here, and so I'm going to go ahead and add a page, calculator page. And let's say I just want to evaluate this expression, x squared minus 3x. So I'll type in x squared minus 3x. And I want to evaluate it at, let's say, x equals 4. So what I can do is where it says control equal sign, the control equal sign is Jeff and I must share that same idea using the such that character and say, I'd like to evaluate this for x equals, let's say, 4. And when I press enter, I wouldn't know it. It is 4. Okay. 16 minus 12 is 4. But what's nice about this is I'm not using store. If I use store, then x is no longer a variable. It's a constant. Where here, I'm saying just let x be 4 for a minute.
Yeah.
So, so I do like the such that command.
Okay.
Right. So hopefully that works. So other things with functions, Jeff said we can do composition of functions and so on. Yes, we can, and also arithmetic. I think we will get to some later, but this one, finding the domain for a function, this kid's really had a hard time with this one today. Okay, none of them thought to graph it to look at it, and that would
Oh,
be the way I would want to
yeah.
look at that. Okay, because this is just an awful looking equation. So I'm going to go to y equals and type in the second square root. And then some of them were typing the minus sign instead of the negative sign, so be careful.
Yeah.
Logs to different bases on the 84 are under alpha window is where the logs to different bases are. And I can type in the base 2 and then right arrow into the argument and type in the x and right arrow still under the radical sign and type in the plus 2. So there's that expression right there in y1. And I can go ahead and graph this. I think I like this window. This window's okay. I'll graph it. I'm getting this funny looking thing here. And this one, I might even go to zoom decimal on this one. Just cut that in half. All right. And also one of Jeff's and my favorite things is the graph table mode. So I'm going to go ahead and go to mode, go down to full, turn right and go to graph table so that I can, so the table might help me with this domain as well. So I'm using graph and table mode.
Now, Tom, does the old silver edition still have that graph table mode?
Yeah, they have it. They do have it. I think it goes back to the 82 or the 83.
It's not called graph table, isn't it? Like
GT,
G-
GT.
yeah.
They don't have enough, don't have the,
You couldn't fit it.
you just can't, yeah, GT. So yeah, please look at that. And so now here's the key. Don't go to the graph from here. Press second graph to go to the table because watch what happens. Notice at -5, there's an error. And that's because you can't take a log of a negative number. So is -4, -2, -1, even 0. You can't take the log of 0. However, notice at 1, as soon as I get to 1 there, it shows up on the graph and in the table. And I just love being able to see that.
Oh, that is nice.
So it looks to me like 4 is included in the domain, but 0 is not. It kind of looks like it might be going asymptotic or something. So now I have a pretty good idea of what this is going to be. The domain is going to be from 0 to 4, not including 0, including 0. So here's a way of me getting the domain on a really ugly looking function by graphing it.
That's when it's a tough function, it's got X in there. If you can graph it, the graph sometimes just shows us the answers. It's
Yeah.
neat.
Students allowed to use more than one calculator to test it. I don't think they are allowed to take more than one. I think they have to use one or the other. But you'll have, Jeff, you would know better on that than I do, but I don't think you're allowed to take more.
I think it's not at the same time. I think there's a way to change calculators.
Okay. Oh,
But
I see
I
what
would
you
not
mean.
recommend
Like if you,
it.
like if your batteries die or something like that. Okay. And then on the Nspire, for those of you using the Nspire, same idea. I graphed it and I have the table. To access the table on Nspire, control followed by T, control table, and then to turn it off is control table. So again, you can kind of see that graph and table and see that this is the domain. And this is that thinking graphically that we're really big on, and so are the test makers. Here's one that talks about composition and range and absolute value and quadratics all in one question. Okay. It says, given these two functions, f of x is the composition in this order, what is the range of f? And this is tough. This is not an obvious one. Okay. So again, how I would want to do this is to graph this, okay, to graph this. And so instead of taking the time to do it, let me show you how I did it. In Y1, I typed in G. In Y2, I typed in H. And in Y3, I typed in Y1 of Y2 of X. I turned these two off so they didn't cloud me. Okay, I didn't get in my way. I just wanted to see the one I wanted to talk about. So by turning, how to turn those off, if you're not sure, you press enter on the equal sign where the black box is and it disappears. And I like seeing the graph and table so I can see that one looks like the smallest y value. So y is 1 or anything bigger than 1. So for those of you there, is that okay that I didn't show that? I mean, I just kind of, I think you could type it. Is that working okay? If not, complain now. Okay. All right, and so this is what it would look like on Nspire. Again, Jeff and I like this idea of how you can define the functions. I define the composition function of g of h of x, and then graphed f of x. And you can see again the range. Okay. All right, here's another one. This is number 38 from one of the ACT tests. Let me give you just a few seconds to read that and think about how you might answer that one. All right, so for this one here, what I did here on the 84 was typed in f into y1 and g into y2. And then y3 was the difference function, y1 of x minus y2 of x. And then I can just go ahead and evaluate y3 at what it says 2, which is really 8. And similarly, I could do the same thing with Nspire, where I define the functions. This time, I didn't define h. I just did f of 2 minus g of 2 to show you get the same answer, but I could have also defined h. Jeff, is anybody complaining that I'm not doing this live? Does this seem to be okay?
No, I'm watching. I don't think it is.
Okay. So, I mean, I'm going to illustrate things live, but I just want to make sure. I want to get to a lot of different things, and some of this is just, rote. All right, so now we're getting into trig. Trig is a big deal. So big that there are actually 3 different parts on trigs. And so the first one I divided into called trig ratios part 1. And here are the things they ask. Given the lengths of the sides of a right triangle, calculate the values of the trig ratios. Given one trig ratio, calculate other ones. Use the inverse trig functions, find missing parts of a right triangle. So those all come from trig ratios. And here are 3 sample problems that we're not going to do. I just want you to see what they are. I do want to look at some other ones, but let me give you a few seconds just to read those over so you can see what type of things your students are being asked to do. So you'll notice in this 15, you're given trig ratio asked to find another one. And this one, you're given some angles and sides and asked to find missing parts. And this one's more of an application type problem. You will notice that they will supply sometimes the trig values approximately in case that you don't have to use the ones built into your calculator, but I find those harder to use than not, but be aware of that they're there.
I never use those. I'm glad you don't use those either,
No,
Tom.
no,
I just use my calculator.
no. All right. So this one right here, okay, we're 2/3 of the way through. This is one that I really spend a lot of time on, and it's a sample question. And so what I'd like you to do is think of at least two ways that you could solve this, okay, with or without a calculator, okay? But let me give you a few seconds to think about that, okay? Because I really want you to try to come up with a couple ways. Okay, about 15 seconds. All right, so for this one, notice it is an acute angle, so we don't have to worry about whether cosine's positive or negative or whatever. Everything was going to be positive in the first quadrant. And so when I did this with students today, this was by far the big way to do it. They made a sketch, either new Pythagorean triples or new Pythagorean theorem. Okay. By the way, if your students do not know Pythagorean triples, they are at a bit of a disadvantage on SAT and ACT. It's much quicker if they would just know that's 5, 12, 13, not have to do, 169 minus 144 square root and all that sort of thing. So this was the most straightforward way, and it's fine. The second way, I was surprised none of them really knew this because they were juniors who haven't talked about Pythagoras's identity. So cosine squared is 1 minus sine squared. And so I could just go ahead and do it this way. Again, we only want the positive square root because everything's in the first quadrant. But it is another way to do that. The third way, I'm going to use a calculator for this. And I would have never thought to have done this as a student, but as a teacher, hopefully you'll see some advantages here. So what we're trying to do is find the cosine when we know the sine. And so when I see sine theta equals 12/13, I can rewrite that for theta is equal to the inverse sine of 12/13. Okay, so I'm going to go onto the calculator and go off to the home screen. And let me just make this regular size here. So I want to find the cosine, so I'll type in the cosine of the inverse sine of 12/13. Because that's exactly what the question is asking. And this is helping my students understand this idea of what does this mean by inverse sine. Now, when I find the answer, it's not like I would want it. But remember, using alpha y equals, we can convert any decimal to fraction or any fraction to decimal, and there's our 5/13. And to me, this is really helps students get the concept of an inverse and what this means. So does anybody else like that one besides me, or am I by myself on that one? Okay, so we have a few. Okay, that's
So
good.
interesting. I don't know why I'm asking this question. It might be a dumb question, but Tom, does it matter if your calculator's in radian or degree mode here?
That's a good question because I wondered about it myself, and it should not because you're going from one to the other, and it doesn't care if you're in radian or degrees. Okay.
Oh.
So by the way, I also did it in degree mode just to make sure that it was right, but it's okay. Yeah.
Yeah.
Good question though. Yeah. All right. So another way to do this is I did it using the solver. So you might just want to watch this, okay? Because I don't think enough of us use the solver enough. So I'm going to go to numeric solver. And notice I typed in sine of x, not theta, on the left side, or expression 1. Expression 2 is 12/13. So I'm going to go and say OK. And I'm in, oh, what mode am I? I'm in radian mode. I think I might want to be in degree mode on this one. I don't think I have to be, but I'm going to feel more comfortable. So let me go down and make this degree mode. And then
What were your
back.
shortcuts to get to the solver again? Can you just redo
So,
that for a second?
sure. Okay. So it's under math. It's the bottom one in math. So if you press the up arrow, it takes you to the bottom because they kind of go in like a circle.
Oh, okay.
So numerical solver. And I'll type in sine of x and 12/13 in the expression 2. Press graph to say okay. Now I have to come up with some kind of a guess, okay? And so I'm going to guess like maybe 50 degrees. And that's why I would rather do it in degrees than radians. I feel more comfortable. And then I'm going to press graph to solve. Now, once I set my guess, press graph to solve, and I'm getting this angle of 67 point whatever degrees, okay? So here's the cool part. When you go off to the home screen, I'm going to clear it. Guess what's stored in X? That value is stored in X. You don't have to write it down. You don't have to copy it down. And now you can actually take the cosine of X and convert that to a fraction. And there's our 5/13. Now, I know that's a long way around. I get that. And I would do this more for conceptual understanding, but that's what we're doing. We're saying, I know what the sine of x is. I can find theta or x and then take the cosine of x to get it.
Right. So you found the angle,
Found the
then
angle.
you're just plugging that in.
Exactly. Because sometimes kids don't know what they're doing. They get an answer, they still don't know what they accomplished. And this kind of
So
tells them what they were accomplishing.
one participant's having trouble with the solver. Can you go back to the solver for a second?
Sure. So I'll press math.
Something about not getting an equal sign. Here's what I'm guessing. Okay, so if you have the silver edition, it does the solver differently. You have to set it equal to 0 first.
Oh, you
And
do?
you type it in.
Oh,
Does it
yeah,
make
you don't have
sense?
two sides. You just have you have the expression, you have to type in the whole equation.
That's right.
So you'd
You
have
have
to
to type
type
in
in
the whole
sine of
equation.
x minus 12/13 equals 0.
Yeah, so if you have the 84 silver edition, you set it equal to 0 and then you do it. But here, I believe if you say okay, Tom, doesn't it automatically type it in with zeros? Like hit okay.
It just
Yeah,
did,
it
no, it types it.
automatically it has an equal sign there.
Yeah, because it's E1 it's not equation 1, it's expression 1, expression 2, left side, right side.
Right. I think when you have the old solver, it's like E1 minus E2 or something like that.
Yeah, I think yeah,
And you have to set it
it's been a
equal to
while,
0.
but yeah.
Yeah, so that's the difference.
Okay. All right, so this one right here, again, this is the type of thing you're going to find out with your kids. When they try these on their own, you'll have kids who will try different ways. Let them bring it up and show them. And if they're
Yeah.
wrong, you might want to show why they're wrong as well. All right, so trig graphing. Two big things that I noticed on the last 8 tests is period and amplitude are tested from graphs and equations. If they give you the graph, they want you to know the amplitude, the period, and sometimes both, or from the equation. So as an example, this is number 50 from one of the tests. And notice here it's saying what's the amplitude and what's the period from that equation. Okay. And we're not going to do that one. I'm going to show you something different. Another one is showing you the graph and saying what is the period in seconds of this function. Again, not asking about amplitude, though they could from the graph. And so what I decided to do was to help students with this, I created a program called period amplitude equation, and then I updated it to 2. So period amp equation 2. So if you do have this and you have it loaded on your color calculator or on your SmartView software, you can do this with me. Okay. Let me go ahead and walk you through this. So under program, I'm going to press the up arrow like we said before because it's towards the end. Notice I have period amp equation. That was my first version. I updated it to 2. So this is the one I want to execute. And I'll run it, and it says sinusoid graphs, calculate the period, amplitude, and equation, 1, 2, or all 3. On equation, note that there's more than one equations possible because you could have sine or cosine, different phase shifts, and so on, positive and negative coefficients, but that's for another day. So that these are randomized, you need to type in a 4-digit number to randomize these, to seed it. So it doesn't matter what 4-digit number you type in. If you use the same one I do, you'll get them in the same order I get, which we don't necessarily want. Graph will be displayed. Mentally think of the period, amplitude, and equation, and press enter to continue. So if you press 3, it'll continue. 99 is when you're tired of doing this, so I'll press 3. And now mine's going to be different from yours. Be aware of that, okay? So here's my first first graph, and we want to know what's the period, what's the amplitude, what's the equation. And let me, in fact, pull this off so we can maybe see this easier. And so from this one here, I'm hoping students can see go from a minimum to a minimum, max to a max, point of inflection to point of inflection, whatever. So they thought about it. And then once they've thought about it, they press enter, and then it gives the answer. And so notice what I'm trying to do with the period. I trace it out in pink so that the students could see it. And the amplitude, I tried to show that is half of from the max to the min. And so that is 1 unit. And this is the equation. This is the sine of x minus 2. So in blue is the equation, pink is the period, green is the amplitude. Question came up, are you allowed to have this on the ACT? Jeff, you can answer this better than I can, but I think you can, right? You don't clear your calculators?
Yeah, but you need to understand that this program is not really a solving a problem program.
Right.
It is a learning tool. Like, you can't plug in the information for that problem the way this program is designed. You can just, like, this is a practice tool. Don't you feel like, Tom, how would you use this?
These are flashcards. These are electronic flashcards.
Yeah.
And in fact, with those kids that I'm working with at the high school locally, they
Now, how
haven't
did they
done
learn
this at
that?
all. This is how they're going to learn period and amplitude by observing. I'm giving them the definitions, but they're just going to kind of go through and practice these until they feel comfortable. And I think it's going to work.
And Tom, this is a big problem. A lot of our students, when they're actually taking the ACT, they might not be in pre-cal yet, and depending on your school, they might not have had this kind of trig at all. Like,
Exactly.
literally, this is one of the holes for a lot of our students. They haven't had this trig. A lot of students, juniors or seniors, are in algebra 2.
Yeah.
And so
Right.
if that's the case, like, you're really behind the 8 ball. And so you haven't learned this at all. And so a little program like this could be interesting. There's a few topics, and this is one of them that a lot of students just don't ever get to before
Right.
they take it.
So I'll show a couple other ones. So 3 to continue. This one here, notice this one is in terms of pi. Once they've checked it out, again, it shows the period in pink, again, which is 4 pi, amplitude is 3. And I really wanted, that's what the change was. I wanted them to see graphically the amplitude, not just give them the answer. We'll do one more. This one, you'll notice the period.
question is, have you written an Inspire version of this? Because this is just such a pretty program.
I just finished it, so I have not, but it's probably something I should do. If someone bugs me and emails me and asks me to create it, I will do it. But if no one asks me, I'm not doing it. You don't count, Jeff. Jeff, you don't count. You're not allowed to do it.
Okay.
So for this one
It's
here,
really a beautiful program. It is beautiful. Just the graphics, the visual. It's
now
really
see on Inspire, it won't be a program. It'll be like almost like study cards. Like I'll have a question on one page, and then the answers will, remember how like they have those like flashcard things where you can show the answer? I could have
Yeah.
something like that, or it could be on the next page.
So the question was, how did you get the x-axis labels in terms of pi on there?
I used the text. I used the text draw under draw. Yeah. So, okay. So, yeah, I got to start to wrap this up. We're getting Yeah, we're getting close to the end here, and I got to give
Yeah.
Mike some time here. So these are some of the examples for that. Um, so things I didn't get to is I didn't get to talk about mean, median, and mode and all those things. So sorry about that. We can say that for another time. And then these are ones that Jeff created that I really, really liked. And I'm going to share with the students next week is some questions you can just type into your calculator and that's it. If you type this in on the 84, it gives you the answer in scientific notation because it's beyond what it can handle.
Tom, can you do this one on Inspire? I know that we're running out of time, but I need you to, I want to show you
So
something you
here's
didn't
what
know that
happened.
you
I
can
did
type in
it on
Inspire.
Inspire, and
No, I
it
need
does
you to
it
type it
rounds
in.
it. It rounds it. You have to change it to exponential or to
No.
scientific
So,
format.
Tom, don't do that. Go to
No?
Inspire,
Okay.
type in the problem.
Okay. So
Just
what was it?
you're going to learn something that you
Uh,
maybe, I don't know, you probably knew this.
No, I didn't know it because I thought it wasn't okay.
Okay, so
Six, or
type
I'm
it
sorry,
in,
3 times that.
6 zeros and 7 2, 3 times 0.6 zeros and then 7 2. Okay, what's neat on Inspire, and you do know this, but you didn't think to do it. To see the whole number, it always, sometimes it rounds it off. To see the whole number, mouse up,
There,
press
there.
enter on Inspire, and it shows you the number. Oh my goodness, it shows you in scientific notation without changing the mode or anything.
That I didn't know.
How
So
about,
I owe you a
do I get a
Pez the next time
Pez?
I
Do I
see you.
get a Pez?
Yeah, I get Pez next time we see you. Yeah. Do.
All right.
All right. Okay, so anyway, I didn't get to those. Sorry about that. So let me wrap this up so I can get it back to Mike. Um, so here's the website created for this. Also, I'm going to plug Jeff and I are doing another one of these on February 7th, but with SAT. More
Yeah.
Jeff, less me. So that'll
I don't know
be
if that's
on
good or
February
bad. I
7th.
don't know if
So
that's good or bad.
that could be a good thing there. And then the programs that are in the folder, Reset Graph 3 is there. And it also has 3 GDBs there in case you want to try those. Those are kind of cool. Pythagorean triples are there. Those are a program to help students learn those. And of course, the one I just talked about. This Inspired document has pre-created windows and grids, okay? Similar to what this does right here. And you're welcome to use those. So I also put some things about the families of functions and maybe some other things, but you're welcome to take whatever's there. And let me see where we are. Oh, 8:57, perfect for Mike. So
Hey,
Mike,
Michael, one question we had for you, Michael, which you might be able to answer. One participant, Mary, said she tried to sign up for the next one, did not get a confirmation. Is it too early for that?
Yeah, just a tad. Normally we're really good with getting like the whole series out, but we have a couple more moving parts this spring than we've had in the past, and so we can't put the whole spring series out for every Tuesday that we're doing a webinar. But Mary, I promise, hang tight. Mark your calendars. We'll definitely be getting that live soon. If I had to guess, probably next few days here. You should be able to check our website, education.ti.com. Again, go into the professional development tab in the middle, go down to webinars, and you can register for that webinar upcoming and then a whole bunch more.
I also have a link on our website, this website page that you can link to register here too, but still not yet, I guess.
Yep, it's not live yet. We're getting there.
Okay. All right, take it away, Mike.
Great
Yours.
stuff,
All
Tom.
yours.
You got it. All right. Definitely some stuff to share that we've learned today. I personally, it's always fun whenever I work with these two guys because I honestly always learn something. And I've been using the 84 since before a lot of you were born, and then the Inspire for, I don't know, a lot of years after that. So it's really cool whenever I get to learn something new that I can use my students and have them hopefully, maybe get a point here, a point there. It's all going to make a difference, hopefully, in the end for them. So very cool that I learned some stuff from those guys tonight. As Jeff mentioned in the agenda, we are giving away to one lucky winner a TI graphing calculator of their choice. And tonight's lucky winner is Sherry Everding. So Sherry, congratulations.
Oh, wow.
We'll be in touch. Yeah.
Hey,
So you guys, you have to figure out what calculator you want.
hey, Sherry.
Way to go.
So we'll be in touch over email in the next couple of days to get some information from Sherry and specifically think about what calculator you want to get. So congratulations. And I just posted in the chat window, you should be able to scroll and get a link for the certificate for tonight. Also is a link for the documents as well. But what you really want are Tom's documents. And I put Tom's link in my documents. But again, Tom's documents are the ones you probably really want anyway. If you're watching this on demand, go ahead and copy this into your favorite browser to receive your certificate. And don't forget to mark your calendars for that February 7th SAT webinar coming up. If you need to get a hold of us, give us a call or send us an email. We'd love to hear from you. And you leave the webinar, a brief survey will appear. We'd love to hear your thoughts, your feedback. Tom and Jeff especially put a lot of time into getting this ready, and they really will listen and appreciate any and all feedback that you have to give. So we'd love to hear your honest feedback from tonight. And with that, just a huge thanks to Jeff and Tom for everything you guys did put together for tonight, and I can't wait to see what you guys do in February.
Okay. Good to see you, Mike.
Same. Thanks, everyone, for joining us, and we'll see you back online next week. Have a great night.